this second example where we're going to look at equilibrium, we're going to do this a little bit with a comparison and almost a statically equivalent kind of situation. Indeed, in terms of the applied forces, they are statically equivalent. Same set of forces, same object. All we're going to do is change this support right here and see what happens. Note that we've got three different ways that we might characterize the equilibrium condition. Sum of force in the x equals 0, sum of force in the y equals 0, sum of moments about a point equals 0. Another way is three different sum of moments. What I didn't write down was two sum of moments equation and a translation equation. We only have ultimately though three independent equations of equilibrium that we have to work with. Okay, so where did my ruler go? Oh, the ruler's right in front of me. Alright, so let's play around with this. Alright, so let's look at the reactions in the first system here, and we'll do our free body diagram. I'm going to make it a little bit smaller than what we've got on screen. Economize a little bit on space here. There's our object. We've got our applied forces of 40 pounds. Remember that number sign or hash mark in today's language is also a pound symbol. So 40 pounds, 50 pounds. And then we have a pin support at A, so there's a vertical reaction, and a horizontal one which we can anticipate maybe going to the left. Let's see if that works out to be correct. We come over to B, it's a roller on a horizontal plane, so that means that it's got to be vertical, and since both of these forces tend to want to spin the system around A in a clockwise fashion, that means BY has to be putting it going in the other direction, right? And so with that, we actually have a pretty straightforward little setup here. Sum of forces in the x will take positive to the right, and we got 40 pounds plus minus AX is going to be equal to 0, and we have a nearly trivial answer that AX is equal to 40 pounds acting to the left. The plus side said acting as shown, right? Then sum of forces in the y would be AY plus minus 50 minus plus BY equal to 0. Well, that doesn't help a whole lot because I got one equation, two unknowns. I don't like that very well at all. Let's sum moments instead about point A. Let's take counterclockwise positive, and we'll have minus 40 times its perpendicular distance of 10 minus 50 pounds times its perpendicular distance of 4 inches, and then plus 20 inches times BY. Set that equal to 0, and I like that one went much better, right? 20 BY is going to be equal to 400 plus 200, that's 600. 600 divided by, and that's units are pound inches, and we got inches here, so BY is going to be equal to 600 divided by 20, or 30 pounds, right? 600 pound inches divided by 20 inches will give us 30 pounds. Right? I could come back up here and plug in and find that AY is going to be 20, but how about we do this independently so that if we have a mistake on the test, we won't end up screwing everything else up and we'll maximize our partial credit, right? I chose point A because I got rid of AX and AY. If we choose point B, it gets rid of AX and BY. So now we'll have 20 inches times AY plus 40 times 10 minus 50 times 16, that's the net of the 20 and the 4, equal to 0. Right? So I'm not going to try to do that one in my head. I didn't do so well last time on that. 50 times 16 minus 40 times 10, or 400, and that equals 400 divided by 20. Ooh, look at that! AY is going to be equal to 20 pounds, just like we said it would. Plug it back into here and we get equilibrium. We did it independently. I think we have a good set of reactions here. Right? So now let's go see what happens when we take this roller and put it on a 30-degree incline. Now, I'm going to be very clever about this because, again, I don't like doing things where I work out all the math and then I find out that I screwed something up. but I don't find out until somebody tells me that you didn't get full credit and you just made a silly mistake somewhere. Don't like that. Right? So I'd like to find ways to get one equation, one unknown. It's a lot easier on the test when I do that. Right? So 30 degrees from the horizontal means that the normal force will be 30 degrees from the vertical. And then we have our reactions AX, AY, and our 40-pound horizontal force and our 50-pound vertical force. Now, one of the reasons why they set this up is to get you to see that here we have AY and BY are parallel to each other. They're no longer that way. And it's because of that, we're going to find out that things are going to change a little bit. Right now, there's a couple of ways we could do this. One, we could split B into BX. That'd go all the way through here and to BY. Notice if we do that, we're going to sum moments about point A, and we're going to get that BY is once again equal to 30 pounds. That's by sum of moments at about point A. I know that's that's intentional. B sub Y and by sum of moments at point A, because the BX part goes through there, but B, the reaction, is going to be larger than that, and it's going to be equal to 30 pounds divided by cosine of 30 degrees. So it's going to increase by 0.86. It goes up to 34.6. Now when I take the sine of that, that will be a half of that, so times 0.5 sine of that. BX is going to end up being 17.32, and that means that part of this 40 is going to go out into or be absorbed by BX, so AX is actually going to be less than that, minus 40. I'm doing all this equation of equilibrium basically right on the spot here, 22.67 or 68 pounds. That's gone down, and AY will still be equal to 20. Why? Because when we sum moments about point B again, BX and BY go away and we get the same equation we did before. Alright, now I ripped through that real fast. If you're a little confused, go back. The key is going to be I can break BX and BY into scalar components. BX goes through point A because of the elevation of point B is the same as A. But look what also would have happened here. If we extended the lines of actions of AY and the reaction at B up to here, I don't know, we'll call this point C, and I sum moments about point C, then we wouldn't have had AY or B, or sorry, we wouldn't have had AY in it. B would have gone directly through, and we would have had one equation, one unknown with AX, and then we'd have to find that distance. It's not too hard to do. This is 20 inches, and so we need the tangent business because that's our 30 degrees, and so that total distance, let's see, 20 opposite over adjacent equals tangent of 30, so that means 20 divided by 30 of tangent is equal to 34.6. That would be this whole height, 34.64, and then subtract off the 10 inches that are down at the bottom if you really care. That'd be 24.64 if you really cared. I don't know why, but it just gives you some sense of how that's all set up. Alright, so well, I guess I do care because I need the 40-pound force there. Right, so if you did that sum of moments about point C, taking clockwise as positive, note what happens. You'd have AX times 34.64 minus 40 times 24.64, and then plus 50 times 4 inches, and that would be set equal to 0. So 40 times 24.64 is that, minus the 50 times the 4 equals that, divide by 34.64, and it should be really close to 20. No, it's not. It's 22.68. Oh yeah, that was the adjusted value, and we did get that. Right, so there's more than one way to do it. I like to do it without having to reuse numbers as much as possible, and I don't have any problem working with right triangles. I love it, in fact.